Thanks for everyone for coming. And let us spend the next hour with the following topic. In a, uh, in a Kaspersky, I'm with the team who is in charge of the researching some targeted malware, doing reversing, threat intelligence, etc., etc. So I would take one research but I hope we would cover not only the research itself, but also some approaches, some interesting technical aspects of this research. And the plan is looks like this. Uh, I don't want to make like a torture with PowerPoint. I hope we will just cover the most interesting parts. Also, the first part would be it's like two parts of this research. First one is related to the on-the-fly file infections. True, it was really the file infection, so it's really added something to the executable files, not so common nowadays. And the TLS encrypted traffic reading. Second one, the more modern part of this research, it's with application and the HTTP statuses as a control server, control commands, server commands. Please mind that Visa here is not standing for the payment system. Visa here, it stands for the Visa, well, like when I want to enter some country. So I hope my English here is right, and I name it right. It's like a permit for me to enter some country to get visa before it. And after some also will describe two approaches, and the approach we promote during this research. And I hope we would have some around 15 minutes for the questions. Please don't hesitate to ask it in Discord. Let us go. Let us go. And in such amount of time, I wouldn't cover all the technical details. For ones who interested in more deep technical details of this research, of this malware, you could find the corresponding materials on securelist.com. And here, I would only emphasize the main parts for me. So how it's all started. If you are into the threat intel, maybe you are remembering the very first appearance of the CompFan malware back in 2014. The company G-Data, I believe it's a German one, it's covering this malware so long time ago. But for sure, I'm not presenting this year some story from the so old days. In 2019, we found new malicious samples, which we are completely sure share the same code base with old CompFan. And Mr. Cooper, if you don't mind, could you please mute your mic? I could hear you. So thanks a lot. And we found the new ones so it's quite obvious code base is the same. And here on this slide, some the corresponding path over this different malware. The idea is so many years passed by, and they already have some proven and well-written malware. Why to make the new one? Why to develop the next version of it with all these new approaches? And the answer is it's related to the encrypted traffic, the TLS. And they was interested in this encrypted traffic from the targets and how they could get it. K-logging, yes, for example, K-logging is a good. It's even before any encryption, they could get it. But maybe with the nowadays security system, it's a little bit too loud. Too loud, any security solution could catch this K-logging capabilities. Sorry, Mr. Cooper, I think it's your mic is on. If you can hear me, could you please mute your mic, because I think all the participants also could hear the sound. If you are with us, please mute. Okay, we'll continue. So, what else? Decrypting the encrypted traffic? I don't think so. With the current current level of the TLS, not in reasonable time. Not. But what else? Certificate to install. To set install, yes, maybe it's a good idea to compromise to facilitate some meeting abilities and not as loud as the keylogging, but imagine the target is inside some huge corporate infrastructure and the authors, the operators don't want to listen all the hosts. They want to mark the precise host of interest and not decrypt all the traffic. Okay, so next idea for them is to mark the packets of interest. But if someone try to make it with some driver and this proxy driver to manipulate this network traffic, it's once again maybe too loud. But in this malware, why we love it and research it, the one technical decision was made how to mark this session, TLS session, without even touch the network packets at all, without any manipulation with the network traffic. So how it's possible? The answer is the client hello field. So for sure you're familiar with on the very early stage of the TLS communication between client and server, you have the client hello field. And let me remind you, this field is completely not related to the encryption itself. So if you spoof this field, you wouldn't weak the encryption. It's just the early stage. Okay, Mr. Server, let us use this version of TLS protocol, etc., etc. So effectively, it's just a random byte to facilitate the starting of the communication between the client and the server. And how they feel. So it's a random field, and for some bytes to be into it, step the random number generator is in use. And this is how the authors of this malware, we call it reductor, this reductor malware, how they mark the TLS section. So imagine, and let me try once again, Mr. Cooper, if you are with us, could you please mute your mic? Because we could hear you as well. So thanks if you are here. And in reality, not so many libraries are in charge of generating these pseudo-random numbers. This, in case of the browsers, for example, Firefox, Mozilla's browser, use NSS, in this case, NSS 3 DLL. Chrome browser use their own DLL, dynamic linked libraries, or quite huge one. And the native Windows application using Windows API, it's just quite obsolete function from Advanced API 32, like a crypt and random. If you consult the MSDN, you would see Microsoft for several last years recommend not use it anymore, guys, quite obsolete. So please move to the bcrypt.dll. So the functions like a bcrypt, again random from the bcrypt, is also the option for the native application. Not so many libraries. So we got two browsers, native applications, 4 libraries. What they've done, they just patch the generator of the pseudo-random numbers in memory, in process memory. In case of Firefox, in the Firefox address space. In case of Chrome browser, in the Chrome browser address space, whatever. So the function of the client hello generation field now is spoofed. So they don't, as I mentioned on the slides before, don't touch network traffic at all, just manipulate the generator. I like this idea. It's so for me, it's quite unusual and quite interesting. That's why I decided to research and cover it. And for sure, to patch, so thanks God, Firefox in source code, so they don't have to reverse the binary code. And in case of Chrome, for sure, they have to analyze this huge DLL, which also includes the SSL capabilities. So to spoof this random number generator, pseudo random number generator. When I take a look at the size of the Chrome library, I decide to analyze Firefox source code, and so with a function like get new random or to this random number generator, it's end up in the SSL3 part of the code, and in charge of the creating of this client hello field. So perfect decision to mark the session. First of all, it's in the very beginning of the TLS session. On the second, it's you don't type the traffic, just fetch something in the process memory. Okay, so what is this unique IDs it looks like? Let's go further. What they put there? And if you remember the slide with all this list of the steps, they could use keylogging, blah, 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 with on some point, the idea of the installation of the certificate authority appears. So yeah, malware holds the certificate in the some host body. They first install it in system, and just to change the, organize the local meeting, if I could say. And the structure itself to mark the traffic, it looks like this. So instead of client hello, please mind it's still random. It's still random. If you saw with, if for example, some IDS, whatever, some security system would try to analyze to the randomness of the client hello, it wouldn't raise any flags, any red flags, because what they do, they just choose some XOR key, first 4 bytes, after it some const to check if it's field or this client hello field filled by the malware, or they don't interested in it, and 2 unique hashes. One hash, it's hardware-based hash. It's in many malware implemented like this. To get the unique target ID, you count the SMBIOS number, some processor features, etc., and counter any hash out of it, and you get the unique ID of the target hardware-based. And also certificate-based, all this some count, some hash of the certificates, and put it also in this field. So quite a solution. XOR key, some predefined const, like an egg, like a check field, and 2 encrypted unique IDs. Also, I really like the Easter eggs inside the malware. In this case, in one place, they run a process remotely, and the credentials to run it was if you take the domain name, a username, user password, you will get with UAC is useless. Okay, in their case, maybe UAC is also useless anyway. It's quite an old mechanism. Now we have a better ones, right? So UAC is useless is the one egg, and you see the one of C2 domains was a confirm.net. And we are speaking about 2019. The name confirm, thanks to the data research, was quite a public one for 5 years already. And anyway, one of the servers was chosen after the same family malware name. Oh, also interesting decision. I like such small things inside the researchers. Okay, so as a result, they let us sum up all these part findings. They mark the TLS session of their interest, even inside the big infrastructure behind the NAT, and after it, they could analyze this traffic and decrypt with using the XOR key inside the client hello field, decrypt the unique target IDs, and decide, okay, this session we are interested in, we could take this data. But the next question appears. How the traffic could be taken after all? It's so on some point between the target and between some website, between some internet location the target want to visit, have to be some host, some interceptor to take it, right? So they install the certificate, they mark the packets, now they could take the data. It's up to you to decide where they could install it. It could be same building, it could be whatever, but from my point of view, so in Ho, it's the best place to put such such interceptors, for sure, it's an ISP. But during the report, we couldn't tell for sure what it's on ISP side, so it's evil is over there because we don't have enough data. We don't know. Maybe with infected files, we see our telemetry show infected files came from some virus site. Maybe it was infected on the virus site already, right? Maybe it's nothing bad happened on the ISP side. But some months passed by, and we see some new URLs also. And this time, this URL were still accessible to analyze data. So firstly, this various sites in use was not, these files on various sites in use was not accessible anymore. So no more files of our interest. But several months later, we could get the files, and these files where target tried to download and downloaded was available and uninfected. So this is all the facts. I enumerate the facts. Files was not infected there. On our target site, they became infected. And the malware tried to facilitate the meeting. Now up to you to decide where the malware could work. Okay, so something in a way happened between the this downloader, this virus website, and the target host. So, and now let us go to the part 2 of the story. So first part was about the TLS and this idea of client hello manipulation. Second part was also the malware with the same code base we came upon right after the first part. And this time spreading mechanism was not the virus sites at all. Well, once again, the operator, Sectors operator, was interested in diplomatic entities, and this time they spoof the visa application. Once again, these are not in terms of payment system, but in terms of the permit to enter the country. Application just to issue the visas to facilitate the visa approval process and on for the consulate for the diplomatic entities. And inside the sample, this application was there. It was the real, the application itself was inside, but not only the legitimate application. Also, the Trojan versions for the 32 and 64-bit architectures were inside. Interestingly, so inside the infrastructure, it's a shared directory on the LAN. So some employee take this from the LAN location with huge file, install this application, and get tryonized after it. And this time, so infection to him is also seems interesting to me, but it's not the most interesting in this case. After Trojans to take the control, the communication process with the control servers is based upon with rare HTTP statuses. So what it means? If you take a look at the request for changes from the Internet Task Force, you would see a huge amount of HTTP statuses. For sure, you know the most popular one, 200, 404, etc. But there are huge amount of rarely used statuses. Like I don't think you are quite, maybe you are. Me before this research, me not with a status like 423 or 427. You wouldn't see it in your daily life. So some funny statuses could name like not from this range, but when I take a look at RFC, some of the HTTP statuses looks like I'm a kettle, I'm a teapot. So it's statuses for all the possible situations for the online. And they use why to invent some readable commands or some codes for the commands if they have these rarely used HTTP statuses. with such a reply, it's rarely the normal server, the legit web server, some Nginx, Apache, whatever, would rarely reply to you with it 400 to 3, right? You could, during the question time, you could argue with me, but from my point of view, it's a very rare situation. And they just use some subset of the statuses as a comments from the so server just have to reply with a just status, and this message body could be empty, so or to hold some arguments for the comments. Quite nice decision. Maybe in my experience, and I'm doing until now for 6 years, maybe the first malware using such a mechanism to communicate. Interesting one. And the funny thing here, they also implement asynchronous, async handling execution of the comments. They wouldn't execute it at once, and they would wait for the status 402 to run all the corresponding handlers for the previously getted comments. So it's a funny thing here. Its status is a payment required. So really, the time to it seems the time to pay. So the Trojan begin to do its work, just to upload, download data, whatever all this remote communication could do. So quite nice multi-threaded and asynchronous part of the work. So it's just a list what the these comments could done. The propagation to the plugged devices, I could only speculate. It could be to go through some air gaps, but to tell you the truth, it's maybe speculation. Maybe they just want to spread. I don't think if the targets we didn't see any industrial targets, so maybe it's not for the air gaps, maybe just one mechanism of the spreading. So what else? So COM hijacking is just the same mechanism of the persistence. Maybe you remember on the first slide for the part 2 of the story. It's also very used in original COM and with Reductor guys also use the same persistent mechanism. This is it. This is how they use this first. The popular one is 200. You see on the first slide. It's just the way how to say, okay. So server, the command server have to reply once with a normal HTTP status. All the another one are not so popular. And let us also take a look a little bit at the encryption schemes here. They are, from my point of view, the encryption here, so by the way, two parts which I try to cover in any report. It's a persistent part and encryption part. So for me, it looks like so useful in any report, besides all the indicators of compromise, all the tactics during the campaign, because it's maybe the targets want to decrypt the data on their side, which was gathered by the what they gather, whatever, and persistent just to rid off of the current campaign. So in this case, encryption in use was RSA mostly, because the corresponding RSA key was encrypted in the configuration data of initial model. Once again, please who want to take a look a little deeper in these technical matters, please consult the securelist.com website with all the technical details. And what else? With the compression, they prefer LVNT1. No, it's because of the usage of the Windows API. Maybe you know the Windows API it's quite with the RTL compress buffer function, quite easy to use such an algorithm. And good old XOR and advanced encryption standard IS is also here. One more thing worth to mention, it's a usage of the HTTP ETAG. Originally, eCheck was introduced many years ago in HTTP to provide caching, not to reply with all the same traffic from to the same request from the same server. But I believe in this case, for sure, it's not about the caching. This unique eCheck, also encrypted into the configuration data, it's mostly to avoid the internet scanners or other the host which try to contact the control server, but it's not the target. You know, if you now would just create new DigitalOcean, whatever VPS instance, and you just enumerate all the scanners which came to you, all the shorthand crawlers, etc., and you would see just in half an hour, you would be huge number of the requests. So I think the eCheck usage is the avoidance of such unnecessary for them, for the C2 traffic, to only to reply to the request from the target of them, not to the crawlers, not to the scanners. Also quite a good decision, I think. This is it. This is it. What was about the encryption on board. And this is maybe the most philosophic slide I ever made because it's almost empty. And this, I hope, with my English, I name it right in English, with partial sum of the row. In Russian, it's if somebody here speaks Russian, just in case, частичная сумма ряда. So partial sum of the row, it's what we found inside the sample. It was returned by separate function and was used as a timeout. Remember, this malware is multi-threaded. And if you use multi-threaded, okay, so no coroutines, no real async await back then. And by the way, it's a usage of C. It's even, you know, it's like a C++, but mostly C. You know, when a programmer develop all the lists and all the vectors by himself, not using the STL, but all the structures developed by the author of the software. So it's more C-like approach back then. So one function, and they have to make some mutexes, some synchronization of the different threads, right? And this function returns the timeout to wait for another thread. And when I take a look at it, and when I understand what it counts, it's count with sum, when you see on your screen. And I wonder why, what is it? What is it? And my university days was so long time ago, and I maybe who from you, it's online, pity. If you will be offline, I would ask the audience who is familiar with such a role, and I believe someone is familiar, but it took me to consult with my mates from the university who remember it. I could tell you guys, this is the exponent. If you want to write the exponent as a row, you could count with not the partially sum of the row, but the full sum of this row would be the exponent of the argument of the A. So some function return exponent, and it's also good idea. And I, you know, for some time I think why they implemented. And my theory is it's a good way to synchronize things. Imagine you have a client software and server software, and your client make a tuk-tuk. I want something from server. I don't know, some microservice, and you want to get some JSON out of it, but server doesn't reply. Nah, I'm not functioning now, and client have to wait. One approach, client have to wait, could wait just a constant time. It's not good because it's, for example, every second, every 5 seconds, or every minute, it would make a tuk-tuk. Is anybody there? Microservice is still unavailable. It's a good idea to make this timeout exponential, because if on the server side, on the microservice, they have some small problem, maybe it would reply just not in 1 second, but in 2 seconds later, right? But if they are completely unavailable, I don't know, the power outage, whatever, maybe it's a good idea to wait larger and larger amount of time, and the exponential growth is good here. So I really believe these guys have a good programming experience because of such a decisions. Let me enumerate it. Time of wait for the synchronization, this idea about the patching of the parent drips of the random number generators in memory, and this idea to use HTTP statuses, I like it. I like it. It seems to me like a creative kind of a malware. Enough for the math, for this small piece of math. And now I think we are done with the part 2. And I promise you the third part, the last maybe around 15 minutes of the talk before the questions. Let us discuss two approaches. Two approaches to do or to use. What I mean here. For me, during the analysis of the malware, two ideas, you could reuse the code malefactors already provided. For sure, if, for example, malware needs to decrypt the next stage, all the code, all the right code is inside the malware. Otherwise, it wouldn't work on the target host, right? And if somebody is good with the debuggers, breakpoints, dumping from memory, the first approach, don't reinvent the wheel. Just use the code you already have. Yeah, it's quite an approach. But the second one, if you want something to do right, do it by yourself. So what it means, no dynamic analysis, just a more static approach. When to decrypt or do something with this sample, it's also just to write your own decryptor or your own part of the software to fulfill this task. Okay, let's take a little bit deeper look into these two approaches. What you prefer, don't invent the wheel, or like Mr. Trump did here, do it by yourself, build the wall by yourself. I have it now, it's another research. I'll just take it as an example of the second approach. What we've done, if you decide to do it by yourself, to build your wall by yourself, we have samples, and it was using the steganography. So on the first stage, it was decrypted the URL to take the bitmap picture from the Legezo website. Cloudinary, check for it once again, completely Legezo. So take it on the second stage, decrypted, injected into system process memory, and the last stage is here to taken from the BMP file and ready to communicate with the C2. And we wrote the decryptor as a standalone application. We don't use just debugging, breakpoint, dumping, whatever. We wrote an application. So what we need here is just so it's just a small C++ app with a two mode of work. You just let the app know I want to decrypt the config or I want to decrypt the bitmap picture. Just to remove the steganography, check from the file with the steganography, because case scheduling differs because of the size, because config is much smaller than BMP, and in this case, case scheduling differs, and algorithms are quite custom ones. And from the configuration, it could get the target ID, URL of the picture. I'm quite sure it's constructed with a builder. So typically, campaign operators have some applications not spread among the targets, only on the operator host. They enter some parameters like a target ID, URL, press the build button, and they get the initial infection after it. And in the bitmaps, only one, besides the network model itself, besides the last stage Trojan, only C2 domain was decrypted. So as a result of this small C++ app, we could get the URL of pictures, we could get the next stage, and the C2 URL. This is it. This is it. And just two case, minus you can see, minus C for the config, minus V for the BMP. And if you compare with a decision during the research, once again, another research, are not related to the confirm. If you compare it with our two pictures, for sure, it's a Mr. Trump's way. Do it by yourself, don't reuse the malware code. And why I think it's preferable. Let me be for a while an advocate of such approach, because all this confirm research was built on this approach, on your static analysis, quite deep static analysis, don't reuse the code, write your own code for analysis the samples, etc. First of all, it's acknowledge separation. For example, here, what I mean, in case of this machine research, we put this decoder, this decryptor on a GitHub. So on a GitHub, and if imagine for 3 years, 5 years passed by, and I forgot almost everything about this decryptor, but I still have the source code for the decryption. I'm quite sure 3 years later, it had to be changed in terms of this custom algorithm of decryption. For sure, malware authors would change the algorithm, but all the knowledge are separated from the researcher. The researcher could move to another company, could even don't do trade and shell anymore, or could forget everything about this research already, whatever. Knowledge is separated. I think it's a good idea. And during this approach, build your own wall by yourself, it's I think it leads to real understanding of the insights of this malware. It leads to the better Yara rules, or to better Suricata rules, etc. So you really understand the protocol, communication between the C2 and the Trojans. You really understand the encryption schemes, whatever. You really understand that all these features like a multi-threading, how they communicate to each other inside the models of this campaign. And also, it's this third point connected to the first one, high reusability. And if you imagine you have 2 dozens of samples, not only one, and you want to take all the common server from it. And if you don't want to reinvent the wheel, and if you want to reuse the malicious code, you would open all this sample in your debugger on your IDE Pro, whatever, just to dynamically take the decrypted C2 out of it, right? And I think it could be a time consuming a little bit. If you once wrote the application, which is also time consuming, but you once wrote it, and you could happily just feed all these 2 dozens of samples to your application, you could pipe it just make a one-liner using SACS, whatever, the tools of your choose, make a one-liner, and you happily get all the next stages, all the URLs, all the parameters. I think it's could be in terms of you have some dozens of samples, you could even save your time despite the programming time you spend on your utility. So this is our pros. I could name for the second way of doing the research, but let us be honest, for sure, first way has its own pros. Otherwise, nobody would use it, right? And first of all, for sure, for the very one sample, you with a debugger and with dumping, memory dumps, you must probably do it faster. You don't need to write your application. By the way, if you have some template and you just have to add some new decryption function, it's became quite faster in doing the new decryptors. And maybe you just don't like to code at all. For sure, many of the analysts are preferred to more familiar and very fast with dynamic stuff, and dynamically could take all this data, decrypted data, like URLs, faster. Okay, and maybe for me, the main plus of the approach, don't reinvent the wheel, it's a far less error prone. What I mean here, when you copy and you write your own copy of this malicious code to decrypt, I mean the decryption part, not the malicious functions per se, you could be tried as like this guy. I see on his screen it's not a programming, it's something like a Wikipedia, by whatever. He has some coffee, has some laptop, and sometimes during the debug, you could, of your application, you could feel like him. If the encryption scheme is quite tricky, it's, why I don't config with IS 256 to the common function. They just make wrote some zeros in the end, whatever. So sometimes during your building your world, you could be child. And for sure, if you reuse the code from the malware, yep, you are on the safe side. Once again, malware, for if malware wants to work perfectly, it has to be implemented right inside itself, right? So you could just execute on your virtual machine the code. I think this is also, I think I'm on time, 40 minutes, like promised, 40 minutes plus. And let me sum up before the question. So we covered two stages of the research of the compound like malware, which I covered from my point of view, interesting tricks like pseudo-random number generators, compromission inside the process memory, usage of the rare HTTP statuses for the comments from the control server, and all the little tricks like exponential growth of the waiting time during the thread synchronization. But besides the covering this campaign itself, I also emphasize these two possible approach and to mostly doing like an advocate of the approach build, not reuse, right? Okay, reuse your own decryptor, your own emulator of the C2 to understand the protocol, whatever. So now I think if you're interested into the source code of the decryptor, it's GitHub is at your service. I publish it, but it's just I think you could easily write it by yourself, so nothing special, just C++ and some decryption functions. So some small framework to decrypt whatever. And what else? If you don't, now we have around, I suppose, 20 minutes for questions. If it would be not enough, please feel free to ping me on some social networks like Twitter, Facebook. So you could easily find me somewhere online to ask something. Okay, I think I'm done. So please, if you have time, I hope so. Let's ask. Let's discuss. Thank you. Thanks for attention.
Thank you, Denis. Unfortunately, we did not get any questions on this topic, so I guess your explanation was spot on.
Nobody's interested in such a topic.
Oh, come on.
I hope not. But in Singapore, it's already 10, almost 11 p.m. Let us hope it's because of the time and the clearness.
Well, this
maybe
talk...
Cooper, maybe you have some questions.
I've been watching, I've been thinking, but like, I understand what you're doing here, so yeah, I'm sorry, no.
Okay, so if it's no questions, then thanks again, and hope to see you on Hack in the Box again.
Absolutely.